And we are live. Okay, talking about standard enthalpies of formation. When we're talking about enthalpy, there's no way to measure the absolute value. So we can only measure changes in enthalpy relative to an arbitrary reference that can be determined. So apparently, chemists have agreed on an arbitrary reference. No one asked me, but the sea level reference point for all enthalpy expressions is called the standard enthalpy of formation. And in parentheses, that should say delta H. And you notice they have a little superscript there. It looks like a degree sign. That means it's the standard enthalpy. And the F means a formation. So that's defined as the heat change that results when 1 mole of a compound is formed from its constituent elements in their standard states. So once we know what the standard enthalpies are, we can calculate the standard enthalpy of a reaction. Again, that should be delta H with a superscript of the reaction. So if we look at this reaction, A plus B goes to C plus D, where the little letters are the coefficients. A plus BB goes to CC plus DD. The change in enthalpy, as we saw before, is the enthalpy of products minus the enthalpy of the reactants. Now the standard enthalpy formation are given in kilojoules per mole. So there's a table in the back of your book, that's Appendix 2, which lists that for all the different elements. So if you're looking at this reaction, if you look at the products, we're going to have the enthalpy of A, kilojoules per mole. Remember the coefficients, enthalpy of A, are the number of moles. So you can take the enthalpy of A, multiply it by the coefficient, add that to the enthalpy of B, multiply it by B's coefficient. So that's the products. That's reactants. Sorry. That's reactants. For the products, it would be C times the enthalpy of C plus D times the enthalpy of D. So this would be the products, and these are the reactants. Really just do the math and add them together and subtract them, and you'll get the enthalpy for the reaction. You have to be careful when you look on that table that you get the right phase. If it's gas, you're using gas. If it's liquid, you're using liquid, and so forth. So here, we're looking at Ag plus Cl minus gives us AgCl. The delta H formation values for Ag plus, Cl minus, and AgCl are, and those numbers are wrong. Go to the next page, and we'll sign what the real numbers are. For AgCl, it's actually negative 127. On the previous page, it said 2127. I don't know why they. Apparently, when they did their formatting, the negatives got changed to 2s. So delta H of AgCl is minus 127. So that's the products. Then you subtract the reactants, which would be the sum of the Ag plus and the Cl minus. And you do all the math, and you turn out the delta H of the reaction is negative 65.7 kilojoules per mole. So really, it's just addition and subtraction, occasionally some multiplication. So here's another Hess's law problem. Apparently they decided to stick in there. Well, we're going to calculate the standard enthalpy of formation of acetylene from its constituent elements. So acetylene is C2H2. What are the constituent elements? Carbon and hydrogen. So carbon, here's where you got to take care. Hydrogen, we don't put H. Remember, hydrogen's diatomic. We have to put H2. Now we have to balance the equation. So I need 2 in front of the carbon. So that's the actual equation we're going to work with. So here's a bunch of different reactions. So again, we have to, like Hess's law, we have to manipulate them so we end up with this. So we're going to start with what equation has carbon in it by itself? Top one. And it's on the left, which is what we need. How many carbons do we need? So we're going to do what to that top equation? Multiply by 2. So there we're going to have 2C, and I'm not going to write the states, but you normally would. So it's 2O2 goes to 2CO2. So the delta H, what do we do to the delta H? Multiply that by 2. So that comes out to be negative 0, 7, 8, minus 787. The next one we need is H2. Which of those equations has H2 in it? Second one. Oh, look. We only have one, so we don't need to do anything with that one. So we have H2 plus 1/2 O2 goes to, where is it going to? H2O. The delta H there, we don't have to do anything, so it's minus 285.8. Well, we have the carbon and hydrogen. Well, we don't have the acetylene. Which equation has the acetylene? The third one. What's on the left? We need it on the right. Flip it. And the equation has 2. We only need 1. Divide it by 2. So if I divide everything by 2 and flip it, I have 2CO2 plus, what do we got? H2O goes to C2H2 plus 2.5O2 delta H. We flipped it, so it goes to plus 2598.8 divided by 2. So it becomes plus 1,299.4, I believe. So now let's check. Remember, we want to get this result. All right. Well, I have 2 CO2s, so those cancel. I have 1 water, cancel here. I have 2.5 oxygen here, and I have 2.5 oxygen here, so those cancel. When I add everything up that's left, I have 2C plus H2 goes to C2H2. So I have what I want, and then I just add up those numbers. and it comes out to be plus 226.6 kilojoules per mole. That tells me if I want to make acetylene from graphite and hydrogen, I have to do what? I have to heat it, because delta H is positive. So this is what type of reaction? Endothermic. Wow, I'm impressed. Okay. And that was the end. Oh, sad.